اليوم نحن في وسط صحراء أريزونا، مكان قلما تزوره الأمطار إلا خلال فترة الرياح الموسمية الصيفية القصيرة. هذا المكان المشهور بأشجار الصبار الفريدة وبأفلام رعاة البقر المغبرين وبالشمس الحارقة هو آخر مكان سيخطر على بالك أن تجد فيه مساحة لدراسة الغابات المطيرة. ولكن ماذا لو أخبرتكم أن هذا المكان في صحراء أريزونا القاحلة يضم غابة استوائية خصبة بأشجار خضراء وارفة، حيث تمطر السماء كل يوم وأحياناً أكثر من مرة أو مرتين في اليوم الواحد. وراء هذا التل مباشرة مرفق للبحث العلمي سنمضي فيه الأيام القليلة القادمة. سنرى داخله كيف يدرس العلماء كل المجال الحيوي للعالم الذي نعيش فيه بطريقة محددة لا يمكن القيام بها إلا في هذا المكان الذي يطلق عليه اسم Biosphere 2. ويمكن وصف Biosphere 2 بأنه آلة ضخمة فريدة من نوعها تتيح للعلماء في جامعة أريزونا أن يلعبوا دور الطبيعة الأم، وتسمح لهم بالتحكم في الطقس ليدرسوا عن قرب ما يحدث لبيئتنا الطبيعية ومحيطها الحيوي عندما يتغير المناخ ويتبدل. يدرس العلماء في بايوسفير 2 المناخات المتطرفة حتى يتوصلوا إلى فهم أفضل وتوقعات دقيقة لما يحدث بالفعل لكوكبنا. في زمن التغير المناخي يحتاج كوكبنا الآن إلى كل مساعدة ممكنة. Hello. You must be John Adams.
I am.
I'm Tony.
Nice to meet you, Tony.
Nice to meet you too.
Well, welcome to Biosphere 2. I mean, you couldn't have picked a better spot than here to see it for the first time.
It is really impressive. I mean, what I see in front of me, it's like an oasis in the middle of the Arizona desert.
It really is. I mean, it's so unique. I mean, you can see the architecture here, and it's striking. It's unlike anything most of us have ever seen.
But why here, John? Why in this location?
You know, first and foremost, when the people who originally built Biosphere were looking for a site, this property, this region has some really unique characteristics. Typically, it's blue skies almost all the time. It's sunny. We have almost 300 sunny days a year. So if you're going to build a large glass structure and you're going to use natural light to support the plants growing inside, this is a great place to do it. The other thing is not much of a danger of getting an earthquake here. So geologically, this area is really stable. So that's another key factor. The other thing is that we're located at an elevation that's slightly higher than the Tucson Basin or the Phoenix, which means, you know, we're almost 4,000 feet here. So that temperature is a little bit more mild, even though we've got cloud cover. We don't get the storms like what you get in other parts of the world. So we don't get tornadoes here. We typically don't get storms that are going to produce really large hail. And as you can imagine, what that would do to a large glass structure. So the environmental conditions were a little bit more favorable than if you built them in another place to control what they were hoping to achieve inside.
Interesting. So mainly weather conditions.
Weather conditions, geologic conditions are really the key factors as to why they selected this location.
Wow, that's impressive. And we have like different buildings. I can see like 1, 2, 3. What is it exactly?
Yeah, let me explain those to you. So right here in front of me, this large pyramid structure.
Yeah.
As you look down it, so the pyramid is the rainforest. That long midsection that you can see a portion of has the savanna, the ocean, the marsh. On the far end, the other pyramid is where the desert is. And so just beyond it, you can sort of start to see the tops of a dome, just like this one that we have over here to our right. Those two domes are the lungs. So these
lungs.
So they regulate air pressure.
Breathing lungs.
Breathing lungs, yeah. So they don't breathe necessarily. They're really a variable volume air chamber. They were designed to compensate for changes in pressure inside. This other white skin portion right in front of us here is what we call the habitat. The people who lived inside Biosphere 2, this is where they had their apartments, they had their dining, their kitchen area.
This is where they lived.
This is where they lived. And then on the back side, you can see 3 arches. So that is the space that was the former area dedicated to their farm that we've converted into what we call LEO, the Landscape Evolution Observatory. This is the world's largest earth science experiment inside there. Here, we are specifically focused on understanding how changes in our environment influence the environments that we live within. How does those changes influence a rainforest or an ocean or a desert area? We can do those types of experiments because the rainforest doesn't just have 1 or 2 plants. It has over 95 different species inside there.
Wow.
The ocean is nearly 1 million gallons. I mean, it's really incredible the types of research that we can do, unlike a lot of other places.
That's really fascinating. How long did it take to build this lake?
You know, that's a great question. It only took them 4 years. So they started construction in the late 80s, 1987. They completed it in 1991. And then in September of 1991, I think this is when many of us began to hear about Biosphere 2. They sealed 8 people inside. In fact, that door that we can see right down there is where they went in. They sealed the Biosphereans, and 8 of them went inside and didn't come out for 2 years.
And this is the very same door we're gonna be taking in right now,
Yeah,
right?
we're gonna go into that door, and I'm gonna show you inside Biosphere 2.
Wow. Okay, John, so I guess it's time to hit the sealed environment and walk through that door.
Yeah, let's take you through the original airlock and get you inside.
Let's go.
So why don't you go ahead and pull on that.
Yes.
We go inside. I'll shut the door behind us.
Wow. So this is the main door here.
This is one of our airlocks.
Uh-huh.
And we've just entered into what we call the wilderness area.
Wow.
This is where the majority of the plants are, and it's really cool in this space because what we have is many different ecosystems inside here.
John, I would like to hear from you. What is it exactly, Biosphere 2?
Biosphere 2 is a completely enclosed or encased system of environments. Now, Biosphere 2 is named because it was designed to replicate Biosphere 1. Biosphere 1's our Earth.
Uh-huh.
And so that was their intentions, to try, in part, to replicate some of those systems, those processes, or capture them inside of this sealed environment.
So, John, tell me, what's the underlying foundation for building such a facility? Like, why? Why would they want to replicate the natural system?
Well, the reason they really wanted to do it is twofold. And if you sort of ask the Biospherians sort of their ideas behind building this, it really dates back to the early 80s. And much like there is today, there was a desire, there was a recognition that we needed to better understand Earth systems. So they thought it was key. If they're going to better understand Earth, they needed to build a laboratory like Biosphere 2. That was the foundation. That was the underlying idea. Biosphere 2 captured people's imagination as a possibility for establishing a colony on the Moon or Mars. Now, I think if we sort of look at it in detail and sort of more critically, remember, Biosphere 2 is a little over 3 acres in size.
Wow.
It's 7.2 million cubic feet. So that volume is equivalent to 82, 83 Olympic-sized pools. That is a lot to move into space, to actually build on a hostile place or environment. Those facilities that we're going to put on the Moon or Mars are going to be much smaller in nature. But the ideas behind how these systems function, how they interrelate, how they support you and I, that is extremely valuable, not only for us who are living on Earth, but eventually for those who travel to other planets.
At the same time, it's a replication of the natural ecosystem, but isolated, completely isolated from it. How did they manage to do this?
What you can see overhead is this metal frame. On top of that metal frame are windows. Those windows are sealed in. What you can see is if you were able to strip away the land and look underneath of us, they actually took stainless steel sheets, welded them together to essentially create a stainless steel bathtub. Then they put the concrete on top of that. Then they built the infrastructure up that ultimately supports Biosphere 2. So that provides a 100% isolation.
That's really fascinating. You mean the minute we stepped into this world here, we're completely now in a different environment?
Well, yes. Now, it has changed because we've changed the use of Biosphere 2 from what it was originally intended to how we're using it today. We're much more concerned with being able to measure and understand the responses of these systems to changes that we induce on them.
It's more now about simulation.
It's more about simulation. It's more about very specific science projects or experiments are directly related to what we see happening on the outside. So we can change the temperature. We can change the moisture, how much water these systems do or do not get. We can change the chemistry of the atmosphere to understand how that changes their response. And that's what's really exciting. These are things that you can't do anywhere else in the world with the control and at the size that we have inside Biosphere. It's the only one of its kind that is specifically dedicated to understanding Earth systems, because we need to understand how those systems change if we're going to be able to anticipate what's coming our way in the future.
So science really needed a facility like this.
Great science is done around the world in many different labs and many different field sites. And we are one of those tools that I think is critical to help aid these other research areas. So we're one piece of that puzzle, but I think we're a really unique piece of that puzzle.
نحن الآن على وشك الدخول إلى موئل الغابة المطيرة، حيث أمضى عالم الغابات يوست فان هارن العديد من السنوات معلقاً على هامات أشجار غابته المذهلة. أعمال فان هارن البحثية تساعدنا على فهم ما يحدث من متغيرات في ظل الظروف المختلفة للنظم البيئية للغابات المطيرة. هذا الموئل هو المكان الوحيد في العالم الذي يستطيع العلماء فيه إحكام سيطرتهم بالكامل على الطبيعة. يمكنهم بضغطة زر أن يجعلوا الأمطار تتساقط أو أن يحدثوا جفافاً كاملاً. Wow, that's a really enormous rainforest here, Joost. Why do we have a rainforest in the middle of the desert in Arizona? Tell me.
They wanted to have as much biodiversity in this building as they could get it. And one of the places of the highest biodiversity are rainforests. Right now we have a fully functional rainforest. And as you can see, it fills the whole place.
Do you have are there any insects living here?
Yes, there's insects like everybody's favorite, cockroaches, ants and things like that. Those are very necessary as well to provide ecosystem functions. And then there are snails, there are worms, other things that live in the soil that help all the processes that mature the soil and function as in the normal rainforest. What we do not have are jaguars or anacondas or any of these large animals.
But there were kind of limitations, right, when it comes to building a rainforest. Is there any difference between what we have here and the real rainforest in the Amazon?
I would never say that we have a replica of the rainforest here in Biosphere 2 or a replica of the Amazon basin. That's just not possible. This is a collection of rainforest plants that function like a tropical forest, like in the Amazon basin. And so what we really use this place for is to understand how do the plants respond to changes in conditions.
And I can't wait for you to show me more about it.
Well, let's go.
Let's go.
Let me show you how we monitor and keep track of what's going on in the ecosystem when we make measurements.
Yes.
And so I'll show you right now the soil pit where we can monitor what's going on in the soil all the way down to the bottom.
Why the soil? What's so important about the soil in a rainforest?
That's where all the water is.
Uh-huh.
So
what's in here?
So this is the pit that we dug so that we can actually, right there you see the tubing go in.
Yeah.
Those are all the sensors that we have at different depths. And so we can monitor it all the way down to the bottom of the soil. And in the real world, you never can do that.
Exactly.
But you
That's
can't
very
dig a pit
impossible.
that goes all the way down to the bottom of the soil.
And how is this monitoring helping you in your research?
So where this comes in very important is that we can trace where the water comes from, which is amazing. The trees here, we cannot rain on this rainforest for more than 2 months. And the trees are fine with it.
But you are able to schedule a rain in this rainforest.
Well, that's another great thing. And let me close this right now.
Yeah. Why so?
The great thing about Biosphere 2 is that we can make it rain whenever we want it to rain.
How often do you make it rain?
Normally, we rain about 3 times a week.
Wow.
So with climate change, we know we are increasing the carbon dioxide concentration because that is driving a lot of the climate change. We know also that carbon dioxide is plant food, but that is limited. They need other nutrients as well. And that's what the trees normally get from the soil. So if you give it just more carbon dioxide, there's a limit to that, how much the trees really need.
Joost, what are your future projects for Rainforest here in Biosphere 2?
One thing we're working on right now is to actually regenerate the understory. So these are the small little plants that never really get up high. And so we need to plant those. And so we started this project, and so you see here a couple of plants that we have planted. This is an Arizona. Right there is actually coffee. And then back over there we have cacao. And so we've mixed in a lot of different species that are also economically important. And especially coffee and cacao, they are being affected by climate change right now as well.
You just mentioned that rainforests are threatened by the climate change. Why is it dangerous for us?
One, we lose a lot of biodiversity. Like for instance here with the temperature increase, we lost a lot of biodiversity here, and there will be a change in species composition, and we get a lot of medications, medicine and other things out of the tropical forest, and so they're really a big resource. Two, if we reach a level where the tropical forests are saturated with carbon dioxide, climate change is going to rise even faster. Now, what can we do about it? One is deforestation in the Amazon basin is one of the major factors. So stopping that, reducing that as much as we can. So that's one big thing. And the other thing is to actually overall reduce our carbon dioxide emissions. So the hopeful message that we've learned here from Biosphere 2 is that tropical forests are a lot more resilient than we give them credit for. Tropical forests will remain as long as we stop the deforestation or reduce it, as well as work more on replanting tropical forests. And the best thing, honestly, in the Amazon you can do is just let the land go fallow, seeds will blow in and forest will regrow.
عندما نعود سنرى كيف يتيح لنا الإبداع الإنساني أن نحل محل الطبيعة الأم. ولاحقاً سننتقل من الغابة المطيرة إلى مياه المحيط المالحة في وسط الصحراء. إن مهمة الطبيعة الأم ليست بالمهمة السهلة، ولكي يقوم يوست بأبحاثه يحتاج إلى مساعدة من المختص في الغابات المطيرة جيسون دلو، الذي يحافظ على هذه الغابة على أفضل حال. Hello.
Hi.
I'm Tony.
I'm Jason.
So nice to meet you, Jason.
Nice to
I
meet you.
heard you got something really cool about Biosphere 2 to show. Is that true?
We are going to show you something really cool.
What is it exactly?
Two things that are really cool. One, we're going to show you how we climate control inside Biosphere 2, how we heat and cool. And then we'll show you the lung, how we maintained originally air pressure inside Biosphere 2.
Perfect. Let's do this.
So let's go on inside.
Yeah. Wow. So are we in part of the Technosphere here?
So this is the area called the Technosphere, about two or so acres underground that support what goes on upstairs in the 3 acres up there. So the atmosphere, rain system, climate, everything is maintained down here, except for sunlight, of course.
Yeah.
That comes in through the glass. What we're walking by right here these are air handlers.
These are the air handlers.
So you can see it starts here and goes all the way down to there. So this is one of the air handlers. There are 26 of them down here. And these are dedicated to each biome upstairs has certain air handlers dedicated to it, to heat and cool and to control humidity inside.
We're literally facing right now the key component of the infrastructure of Biosphere 2.
Absolutely, yeah. For example, if we want a biome upstairs to be drier, less humidity, we can run cold water through those coils, and as the air crosses them, the moisture condenses out.
Interesting.
And then the air on the other side will be drier.
Wow.
What we can then do if we just want dry air, we can dry the air down and then warm it back up.
That's fascinating. Really, that science behind it is really impressive.
Oh yeah.
It's really impressive. Which biome uses the most from this air system technique?
Probably the rainforest.
Rainforest.
Especially when it gets cold, we need to keep it warm in there because those plants in there can't tolerate. So we'll head on down and see the way that we maintained proper air pressure inside. Because if you imagine Biosphere 2 was like a sealed bottle, and you put it on your stove, and you turn the burner on, the temperature is going to go up inside the bottle, right? And so eventually the bottle will explode. Right. The same thing would have happened in Biosphere 2 upstairs. If the sunlight coming in heated things up too much, they would have exploded. But it didn't happen because of what we're going to see right now.
Wow. The air pressure system.
Yeah. So this is our tunnel. Looks kind of almost like a ship or something like that.
Yeah.
In fact, these doors were ship doors. So we'll go down this tunnel to the lung, about 200 feet long. You see it's mostly on a decline. So just watch your head and watch your step as you make your way inside.
Interesting.
So the air, when it got warm inside Biosphere 2, the air would heat up and it would expand, right? That expanding air would get pushed down this tunnel, this very tunnel.
Through these pipes.
No, through the tunnel itself.
Through the, oh, wow.
Yeah.
Wow.
So it'd be pushed down through the whole tunnel and it'll come out down here. And here we have a small little access. So watch your head.
Yes. It's like a spaceship.
Yeah.
Wow.
This is the lung.
Oh my God, this is impressive.
So just like our bodies have two lungs, Biosphere 2 has two lungs.
Yes.
To help movement of air and things like that.
Wow.
And so this is the domes that you can see from the outside. We're in the south lung. There's also a west lung. This lung is composed of two main parts. So this part above us, black, is a synthetic rubber diaphragm. And that is really what catches and holds the air in here, okay? And attached to that diaphragm is this big disc, okay? It's made out of aluminum, and that's what causes it to go up and down. Now, imagine this. The two components that make up this lung that are literally floating in the air right now, the diaphragm weighs 4 tons, and the disc weighs 16 tons.
What?
So 20 tons of material
Above us
is
right now.
being held above us right now, and it's being held up there only by air. That's what blows your mind.
It is really speechless. This is like a mind-blowing concept to fathom. Like,
Yeah.
it's really, wow.
We do not use this as it was originally intended because we're not a sealed system anymore, right?
Exactly.
So air comes and goes, our doors open. So it's not completely sealed airtight anymore. But we keep this up artificially through the use of fans that are on the outside of the dome that you can see from the outside. And so that makes it a unique opportunity for us to allow this to come down without compromising what goes on inside Biosphere 2. So we can go over to that door over there and open it up and let some of the air out and then see what
I would
lung
love
does.
to see that. Yeah, let's go.
Let's go have some fun. So I think what you'll see here is just gonna blow your mind again because it's just amazing. You're just gonna open this door, and the simple act of opening this door is gonna
It's gonna like make this come down.
it'll make the disc come down.
Go in. Oh my God, that's a lot of hair. Where? How? Woo! Oh my God. That's a lot of hair. Oh wow. It's like being like skydiving.
So we'll let it come down just a little more, because what we're doing is we're basically letting air out of there.
Yeah.
So
How long do you usually do? Like for how long do you keep it open? For the disc to go down.
We're almost ready now.
Okay.
Close now.
Can we see it? Oh wow. Wow. That's a lot of air.
So
It
now-
is lower now, yeah.
Yeah, it's probably come down several feet. So you can just grab on and hang and pull yourself up with that.
Do you think I can do that?
Yeah,
It's okay?
Yeah, sure.
Is it safe?
Now watch the whole,
Oh wow.
yeah. So you see what you did?
It's moving. Oh my God. Oh my God. Now it's going up again.
Yeah, it's
I'm gonna bring-
kind of going back and forth like this because you threw it out of balance
Yes.
by hanging yourself on it. So
It's moving.
So imagine What this is kind of like is if you have a cup of water with an ice cube in it, and you tap that ice cube, you know, it kind of bobs around for a few minutes, and then it finds its equilibrium. This is doing the exact same thing.
Oh,
but
wow.
the part that's really amazing is it's doing it in the air, not in water, right?
Yeah.
And so you threw it out of balance for just a few moments, and it'll eventually come back.
Still moving now.
Yeah.
That's impressive.
16 tons is going to take a while for it to balance back out.
I just made 16 tons moving like this.
Right.
How strong I am. Wow, this is really cool.
That's right.
إنه لأمر مدهش أن بإمكاننا في صحراء أريزونا القاحلة أن نبتعد قليلاً عن هذه الغابة المورقة، وعلى بعد خطوات فقط نصل إلى المحيط. محيط من المياه المالحة بأسماكه وتنوع حياته البحرية. هناك سنلتقي بمديرة الأنظمة البحرية كيتي مورغان. Hello.
Good morning.
You must be Katie Morgan.
I am. It's
Who
great
else am I gonna find here on
Right?
this ocean, right? Are you in the middle of something? What are you
Oh,
doing?
I'm just doing our daily checks on some of our animals that we have in one of our tanks.
What's the idea behind having an ocean in Biosphere too?
This system was built during the original experiment, and they wanted to have it for a few reasons. One of the reasons is that our oceans actually produce a lot of our oxygen that we breathe. During some times of the year, it can be up to 70% of the oxygen being produced in our atmosphere is from the ocean. So they wanted to have that balance of oxygen production from rainforests and all the trees and all the plants that they put in here, but also to have an ocean that would potentially produce some oxygen as well. So they brought in ocean water from San Diego.
How did they do this? Like, how was it built? I mean,
They actually brought it in milk trucks. They loaded up milk trucks and drove them here and imported some of that ocean water, only a percentage, but some of that ocean water into the system. It is the world's largest research ocean.
wow, that's crazy. And are you able to monitor the level of its nutrients and everything?
Everything. So we do a lot of work in here. Most of what my job is, and a lot of our team, is monitoring this system. So we take samples every week, multiple times a week, to look at the nutrients, the water composition, make sure that salinity, the temperature, the pH is all at a happy medium for all the animals that live in here.
Wow. Have you done any massive change for the water ever since it was built?
The water, since it was built, has gone through some different changes, and it's been through many different kinds of research projects. Columbia University did a research experiment where they actually acidified this water. They wanted to see what happened when increased carbon dioxide went up in our atmosphere, which we knew was happening.
Yeah.
So they did some future predictions and say, okay, what's gonna happen in 50 years? And they went to that level and they acidified this water to see how that coral reef would survive or not survive. And it turns out it gets very stressed out and bleaches and algae ends up taking over. And they were able to see that whole process of the corals being stressed out and link it to the increased carbon dioxide in our atmosphere.
Wow, that's impressive. What are the major researches now you're conducting in the ocean here?
Yeah, so today, our main focus is really on the main stressor to corals today, which is temperature. What's different today is that it stays warmer for longer. So these corals are more and more stressed out. So instead of having a 3-day warming period, it can be 3 weeks to 3 months.
Wow.
So we're losing corals rapidly. Corals are so essential for so many reasons. About 25% of marine biodiversity from all over the ocean spends at some point of their lifetime in a coral reef, whether it's at a larval stage or they hunt there or they use it for protection. So for animal diversity, it's very important, but also for countries that depend on fisheries, communities that their entire livelihood is around tourism, people coming out, they want to see a beautiful reef. The oceans are amazing. They are basically a sink. They take in all that excess stuff, whether it's CO2 or temperature, increased temperature, and there's a chemical reaction that happens that makes that water more acidic. And the problem with having a more acidic ocean water is that a lot of these animals that we depend on, including corals, build their skeleton, right? So snails, for example, clams, oysters, they build their skeleton. And if the ocean's more acidic, they have a much harder time doing that. But the reality is that they're facing both things. They're not just facing increased temperature, they're also facing a more acidic environment. So there will be studies that we're going to be conducting that puts them under both stressors to identify what the solutions are to make them be able to withstand both of those things.
And also they're threatened by other creatures in the water, like algae.
Yeah, no, it's a huge competition. And there's a very delicate balance within a system. After Columbia's experiment with the acidification, our reef became completely dominated with algae. So this system right here, we have been battling for years of actually removing algae and working on bioremediating, which is basically using biological methods to get it back to normal. So we've actually introduced species like urchins and different kinds of fish, hermit crabs, snails.
Why did you do this? How does it help?
They actually eat the algae. So they come in, we introduce them, and they say, great, they've got a consistent dinner time for the rest of their lives because there's tons of algae for them to eat. And on top of introducing the species, we actually have gone in and manually removed algae. About 15,000 pounds of algae we've removed by hand out of this system, just to tip that balance back in favor of being a place that we can grow corals again.
And all in order to restore the coral reef.
This system is so unique. There's no other place like this. And why it's unique is that you can do all kinds of experiments at a small scale in the lab setting. But then expanding it to the natural system is difficult. You have to get different kinds of permits. You want to make sure that what you're researching isn't going to affect the environment, isn't going to affect the sediment or the other animals. And so having a place like this that has a full ecosystem, from sediment to microbiome to fish, invertebrates, and to corals, we can understand how some of these solutions might impact the full system and then make a choice about what are the solutions that are going to work in different locations around the world. Now, this poses a unique opportunity for us because we can control and monitor everything.
So everything that you cannot really do or conduct in the big ocean, you're able to do it here.
Absolutely, yeah. So it gives us this platform to do really unique research, and it allows us to try things that might be risky, right? Things that you might not want to try in the natural system yet, but is a very viable solution. So we can try these novel and risky solutions here before we do it anywhere in the natural system.
And at the same time, we all know and we are aware of the global warming, the climate change, and how it's affecting our ocean. But at the same time, we don't know what to do to help or to contribute in protecting the ocean. Can you tell me what to do as individuals?
So I think some of the most important things that we can do is really watch what we consume. So whether it's consuming plastic goods, right, making sure we're cutting down on the amount of plastic that we're using, being conscious about how much seafood that we're consuming, whether it's sustainable, where it's sourced from, how it's fished. Every little thing makes a huge difference in the end. And we need to just step up and be better about that, because if every single person was better about it, we would have a lot less issues in the ocean.
عندما نعود سنتعرف على اختبار علمي فريد من نوعه سعياً للإجابة على السؤال التالي: أين تذهب المياه بعد أن تمطر السماء؟
We've got an automated system, so with the press of a button, I can make it rain on the slope just right above us.
That's crazy. لا يمكنك أن تتخيل مع كل الأعمال البحثية التي تجرى هنا يومياً أن يزور هذه المنشأة العلمية أكثر من 3 ملايين سائح وسائحة في كل عام. لكن تثقيف عامة الناس بقضايا المناخ هو هدف شديد الأهمية بالنسبة لبايوسفير 2.
The University of Arizona assumed ownership of Biosphere 2 almost 13 years ago. And the way in which they're using it is a large earth and environmental science research laboratory. The most serious issue that's facing our future is not understanding fully the implications of global climate. We know the climate is changing. We know in many cases that our interactions are changing the environments and the conditions, not only that we live among, but also things that are happening globally. And so being able to predict and understand what those are is critical. Because again, I can't say it enough. that if we don't know what's coming our way, if we can't adapt, we're not going to be able to survive. And the only way that we're going to be able to adapt is to be able to better understand the current state of those systems and how those systems are responding to changes that we see. These facilities are crucial. A place like Biosphere 2 is unlike anything else in the world, and it gives us a really unique opportunity to better understand complex Earth systems, but in a way that we can actually leverage it. And it's that understanding that's not going to just benefit the researchers here at Biosphere 2, but it's also going to benefit researchers around the world because we share our information. We're hoping that people can take that information and apply it to their specific studies to further expand their knowledge and understanding. And the only way that we begin to try to better understand some of those systems is to do experiments and to do experiments and to do experiments. We have to repeat those things because it does change. And as complex as Earth is, we've only scratched the surface of understanding it.
So this is our coral raceway room. This is where we do a lot of our research. In this tank, we have actually some of our corals.
Wow.
That are living in here. So these guys are getting acclimated to be ready to put actually into the main ocean system. And just hold it right down there.
Here? Wow. So that's a coral
That
here?
is a coral right in front of you.
Light is very important for corals, right?
Very important. Corals inside of their tissue have this plant cell. You can see those kind of glowing parts in here.
Yeah. Wow.
So this plant cell is called a zooxanthellae. And this is what actually provides a lot of the energy for the corals. These guys require that they have light in order to photosynthesize. They need sunlight, or in this case, artificial LED light, which does the same thing. The majority of corals in our oceans require light. So this coral, for example, had a stress event. You can see how this is different colored than this, right? So we knew that it was becoming stressed out because we could start to see that gradient. So that tissue started turning a different color, which a lot of times indicates that little plant cell, something's going on. We have someone here every single day of the week that is checking on these corals, making sure that they're okay, they're healthy, the tank is healthy, everything is going well.
Wow, Katie, what a privilege to have like a private lesson about coral.
Good, I'm glad. I'm so happy you've been able to see it all.
Thank you. What else are you going to show me?
Yeah, so I really would love to show you our mangrove ecosystem as well.
There's a mangrove this week.
There is.
Wow. Let's do this.
All right,
let's go. Wow. That's tricky in here.
Yeah, it is tricky in here.
Awesome. So, this is the mangrove here.
This is the mangrove.
But why do you have a mangrove?
Originally, they really thought that they needed to have a mangrove system attached to the ocean because that's what we see a lot of times in nature. We see these estuaries or these mangroves, freshwater, brackish, you know, a combination of salt and freshwater systems attached to the ocean systems. And they're a lot of the times very important for animals. They use them as breeding grounds. And because the large predators can't get in, they're much more protected in mangrove systems.
How is this mangrove helping like the research that's taking place here?
It provides us a model system. So it allows us to do research in here and compare it to the mangroves outside in the natural systems. One thing that's different about this mangrove system is we don't have a lot of insects that are eating or preying upon the leaves. That herbivory of the leaves is something that they really run into problems with in the natural systems. So we can compare those stress differences in the trees to ones that aren't undergoing that insect stress to trees in the natural systems that are.
What are you working on right now?
Most of our intentions right now are on the ocean, but there are lots of questions about mangroves because they're so important. They are a place that a lot of those animals can go and grow up before they're strong and big, can go back into the ocean. Because of their unique rooting structure, you know, how it's kind of intertwined, they actually prevent a lot of erosion.
Nice.
So we see them being incredibly important in coastline areas. And they also are kind of natural purifiers.
Definitely.
They extract a lot of that excess nutrients from the water and actually clean up the water a lot. So they're very important around the world, and we need to do more to protect them.
So, John, it's clear that water is a very pronounced and present component in your research here. Like, you have the ocean, you have the rainforest, like, it is like everywhere. And it is at the same time one of the most important source of life for our planet. Tell me, how does it resonate with your research, with your work here in Biosphere? What is it so important about water that we need to know?
I mean, you're right. Water is the foundation for life. It's, we refer to it as the universal solvent. It's, in my opinion, and a lot of the folks that I work with, is that global climate change is going to impact the presence or absence of water probably far greater than any other resource. And so understanding its behavior, how changes in its presence or absence is going to in turn change the behavior of an entire ecosystem is critical. Because when we think about it and we start to look at conditions in different parts of the world, we either have too much water or we have too little water. It never seems like there's sort of just that optimal amount. Understanding the behavior of water, especially subsurfacely, is critical. That's why we built LEO. As the landscape around us changes, as we see vegetation changes, how does that change then the dynamics of the water cycle? And again, it's not above the surface. It's pretty easy to observe, measure what's happening above the surface, but when it goes below the surface, it is still very much that black box for scientists. They just don't know really what's going on. They've got ideas and we're continuing to learn, but we want to know more.
سنحاول الآن أن نعرف أين تذهب المياه عندما تمطر. قام العلماء ببناء تشكيلة ضخمة من مساحات التربة الاصطناعية لتساعدهم في الإجابة على هذا السؤال الصعب. دعونا نلتقي بالباحث آرون بوجيه. Hi, Aaron.
Hey.
I'm Tony.
Tony, Aaron,
So
great
nice to meet you. I heard you're working on a very special project here.
We are. So this is called the Landscape Evolution Observatory, and what we're really doing here is tracking where the water goes. Now, we love to study the invisible processes of water. We often think about water as falling as rain, but once it leaves that visible puddle that we can see on the ground, it doesn't just disappear, it goes somewhere.
And why do we need to know where it doesn't go?
We know that we're running out, in some cases, of drinking water. We're running out of land that's viable for plants and crops. So understanding why water goes where it goes and some of those systems as to how it is stored, that's important for us looking into the future.
What is it exactly that's what we see in front of us?
Yeah, we've designed an artificial landscape. We've built a landscape from the ground up. We embedded it with lots of sensors that can tell us information about where the water is in the ground. And then we create our own rain events. So we have sprinkler systems all up and down the sides of the slopes. We rain water that mimics what real rain does. It's the same velocity, it feels like rain. That water lands on the landscape and we track that water as it moves through the soil. It goes to about 1 meter deep, so basically from my neck down to my feet.
Wow, interesting. And this soil, it's just normal soil?
This is volcanic soil. A lot of our earliest land formations stem from volcanic processes. So you think about Hawaii. These volcanoes start underwater and they build on top of each other, up and up and up. They become islands. This material, it's basalt. It's very similar to Hawaiian volcanic lava. We designed 3 identical landscapes. So we're at the center slope here. We have our west slope and our east slope.
Okay, so let's check the west slope.
Perfect, yeah, follow me.
How do you make sure that the whole landscape, like water is getting equally on the entire landscape?
When we first built these landscapes, to calibrate all of our rain and sprinkler systems, so we actually had to lay down several thousand cups across the entire surface.
Cups.
Cups, like drinking cups.
Wow.
But we made sure that our sprinkler systems filled those cups in equal amounts.
Aha.
And that's how we know that we have a uniform distribution of rainfall across our entire landscape.
That's very smart.
Yeah, these mosses here are called bryophytes. They're early desert colonizers. So we have volcanic mountain ranges in the desert, and these are the first signs of life that would grow.
وفيما يبدو لك وكأنه مساحة طبيعية جرداء، سيتكشف أمامك عبر عين العدسة المقربة الخاصة مشهداً يشبه الجبال والوديان، تملأه النباتات وتسكنه الحشرات الدقيقة. إنه لمدهش حقاً أن تجد هذا الكم الهائل من الحياة يختبئ في هذا المكان.
Let's go down to the underbelly and I'll show you from down there looking up.
Okay, let's do this. Thank you.
Yeah. So we're walking through one of the original sealed doors of the Biosphere.
This one?
Yeah, you know, back when this experiment was first started, they would seal all these environments tight.
Another airlock, right?
It's an airlock, yeah. So it's like an old submarine door.
Yeah. So now we're under the slope.
We are under the slope. And remember I told you we had several thousand sensors embedded in the landscape. You can actually see some of those sensor bundles coming out of the soil.
Yeah.
You can see the little holes.
Yeah.
And what's cool about what we've created here is that a lot of our sensors are automated now. So we can measure the soil chemistry and the water chemistry of the entire landscape almost simultaneously. So imagine being able to say, oh, the top slope is showing signs of sodium enrichment and the bottom slope isn't. Those are the kinds of things that we can see. It's like we have 2,000 pairs of eyes in the soil.
Wow.
Yeah.
So it gives you literally what's going on in every
XYZ coordinate. Yeah. Researchers are usually wowed by our ability to measure the gas and the chemistry in the soil so fast. To be able to get a snapshot of soil chemistry on a landscape this big multiple times in a single day, that's impressive. We can turn to you and we can say quite confidently, this is what's going on right now.
Wow, that's impressive. And where do you make it rain from, like exactly?
So we rain right from our control center right here.
Uh-huh.
And we've got an automated system, so with the press of a button, I can make it rain on the slope just right above us.
That's
so,
crazy.
Yeah, I'll go ahead and do that for us.
Can I press the button?
Of course, yeah. So now we're running our pumps. And I just want you to press Leo Center Multi-2. And we'll press open.
Yes. And I'm gonna make it rain. This one, right?
Yep, just give it one click.
Let it rain.
And you'll start to hear the valves opening.
Oh my God, yeah.
And now you hear the rain.
It's raining.
It's as simple as that.
Wow. Wow, that's really, really fascinating. This whole LEO project is very important. I mean, the more you explain to us about it, the more we learned about it, the more we can understand now how important this relationship between soil and water, and where does water go, right?
Yes.
That's the main question that you're trying to answer.
Yep, that's what this is all about, and I appreciate you taking the time to come and ask those questions. Well, I'm glad I could give you your very own light desert rain shower today.
I know that. For the very first time, I was able to make it rain.
There you go.
ما توصلنا إليه هنا خارج المسار في صحراء أريزونا هو حيثما وجد العلم تجد الأمل، وتعلمنا أن الأرض، هذا المجال الحيوي الذي نعيش فيه، هي مكان يتطلب الكثير من العناية وقدراً أكبر من الاحترام والحب. بايوسفير 2 هو مشروع فريد من نوعه، فهو يفتح لنا نافذة تطل على ما ينتظر أرضنا من مستقبل. ورغم تقدم العلم والعلماء وحداثة المختبرات، يتطلب هذا المستقبل من كل واحد منا أن يقوم بدوره. فإعادة خلق ما قدمته لنا الطبيعة الأم ليست بالمهمة السهلة. أنا توني نداف، أراكم في الحلقة المقبلة من خارج المسار.
These are little pencil urchins. They're very stoic.
They don't look like alive, right?
I know, I can feel him barely moving on my hand. You want to hold him?
It's not gonna bite me.
No,
not gonna do
this
anything.
one's fine.
Oh yeah.
You can feel it, just like little movements.
Little tiny. Yeah, it's moving. Yeah, it's interesting.
I don't pick up, where's Spike? That big one right there by you.
This one is aggressive.
His little spines are now very big, and so he's harder to handle.
Yeah.
So in my opinion, the most important lesson learned from Biosphere 2 is just how little we understand Earth systems, how infinitely complex they are, and that no matter how much knowledge we think we have, we're nowhere near being able to recreate Earth in its entirety with all of those complexities inside of a facility, even like Biosphere 2. And so for me, that's a recognition of how important it is to continue to strive to understand Earth systems, to ensure that we're not adversely affecting those systems and that those systems are going to be in place for generations to come.